Facts about limits. The limit as u approaches 0 of sine of u over u or its reciprocal equals 1. The limit of tangent u over u or its reciprocal also equals 1. So I could write that a little better. Tangent u over u. And also the limit as u approaches 0 of 1 minus cosine u over u equals 0. That would also be the limit as u approaches 0 of cosine u minus 1 over u. You can't take the reciprocal of it because that would be undefined, but you can take the opposite like this. Alright, so we'll be using those facts. So even one like this, if you have the limit of the sine of, let's say, x minus pi over 2 over x minus pi over 2 as x approaches pi over 2. It doesn't really look like it fits this bill. It doesn't look like it fits that rule of our three limits that we're working with. However, if I let u equal x minus pi over 2, then what happens is I get the sine of u over u, and the limit, notice as x approaches pi over 2, u does approach 0, so that one will go to 1. So you could even have u substitution. I don't know that that comes up in any of the examples I gave you, and I'll be looking at the examples I gave you when I make out your quiz. I'm going to do a few examples from the sheet that I gave you where you have the answers, but I just want to give you a little guidance. This won't last long. Okay, so let's look at, if you pull up your worksheet, homework on trigonometric limits, which is really not your homework, but it's just a study sheet with answers you can look at. I'm going to be doing 1B. Okay, so 1B. So I have the limit of sine 6x over cosine 4x as x approaches 0. First rule of limits is fill in the number, and you get 0 over 1 is the cosine of 4 times 0. So this one is just 0. So you don't have any little tricks to do with that. Now let's go to F, 1F. On 1F I have the limit as x approaches 0 of 2 tangent squared x over x squared. Okay. The 2 I could even factor out to the outside or just leave it there. It'll come into play in a minute. I'm going to break this up into tan x times tan x, and the bottom is x squared x times x. So I have just enough to call this one and this one. The limit of that number would be itself, so that would be 2. On H, 1H, you have the limit of sine x over 7x as x approaches 0. I'm going to rewrite that as the limit as x approaches 0 of sine x over x, and I'm going to kind of call this like a 1/7 out here. I'm going to separate this statement. That goes to 1, and I'm left with a 7 on the bottom. And so if you check your answers, H is 1/7. Now, let's see, let's go to J. And you might want to turn off the video and try some of these on your own, but I'm just giving you some ideas of what can happen. So you have 1 minus cosine squared x over x squared. It looks kind of like one of the main rules. Sorry, it's not really oriented. Let me do it this way. It looks kind of like one of the main rules up here with the 1 minus cosine. However, it's squared, and so hopefully, this is cosine squared. Hopefully, you automatically think of that as sine squared x over x squared. And similar to what I did with this one, that gives you sine x over x and sine x over x. So that one goes to 1. That's J. Let's see which other one I'm going to do. Wait, and looking at the answer choices, it says J is 0. But that should be, oh, I'm sorry, I skipped down. I didn't realize I had done that. This is 3J, not 1J. That's 3J. So an example of that one. Let me look at the answer choices there. Okay, so I'm sorry, I didn't realize I had scrolled all the way down to that. Let's go back up though to 1. Example 1, letter K. You have the limit of sine squared 3x, if you look at your sheet, sine squared 3x over x squared as x approaches 0. Let's break that up and call it sine 3x over x, sine 3x over x as x approaches 0. I wish there was a 3 down here, so I'll manage that in both places. This goes to 1, this goes to 1, and so 1k should be 9. Let's see if there's anything else that I want to do for you. Let's look at 2a. And I'm trying to think if I want to do that one for you or not. I'll let you think about that one since you have the answers. So you may want to try it a different way, but let me do 2a. All right, 2a is the limit as x approaches 0 of x over the sine of x over 2. If you fill in 0, you definitely get 0 over 0, but then you think, well, what am I going to do? Well, remember, this could be flipped and still equal 1. And so what I'm going to do, I'm going to take the limit as x approaches 0. I want this to be sine of u, and I want this to be u. So I'm going to make it x, I'm going to divide it by 2, and then multiply it by 2. This is u over sine u, and it fits the 0 over 0. So you would have 2 times 1, or 2. I don't want to do too many of these so that you can think about them yourself. Let's jump down to number 5. 5e. So on 5e, I have the limit of the cosine of pi over 2 minus x over x as x approaches 0. In pre-cal, we didn't do it much in either class probably, but you learned the cofunction identities. Like if you have the sine of 30 is pi over 6, and the cosine of 60, I'm sorry, that made no sense whatsoever. I was distracted, sorry. I'll get it right. That was crazy. Sine of 30 is 1/2, and cosine of 60 is 1/2. Are you waiting? I'm sorry, there's people here. Are you waiting on me? No. You're just watching.
I thought you were saying.
No, I'm making a video. Okay, so sine of 30 is 1/2, and cosine of 60 is 1/2, and these are cofunctions. And so if I go into radians, that would be the same thing. But basically what I'm saying is sine of theta will equal the cosine of theta minus pi over 2, or theta minus 90 degrees. But notice this is backwards of that. So this equals negative sine x over x, and that fits the sine x over x is going to 1. And, oh, I'm sorry, I wrote this part wrong. This would be pi over 2 minus theta. In other words, if this is theta, this is 90 minus theta. If this is theta, this is pi over 2 minus theta if I'm in radians. So this is positive, and I get 1. Another way to look at it, though, is if you don't remember, let me write your cofunction identity since I messed this up over here. The cofunction identities tell me the cofunction is sine of theta would be cosine of pi over 2 minus theta. That's why there's sine and cosine. Secant of theta is equal to cosecant of 90 minus theta, or pi over 2 minus theta. Same is true for tan and cotan. If you didn't happen to notice that, you could also have done the sum and difference identities. Cosine A minus B goes cosine A, cosine B, plus sine A, sine B over x. And then you know the cosine of pi over 2 is 0, so that knocks this out. The sine of pi over 2 is 1. And so you see you're left with 1 sine x over x. You could also have done it that way. But the cofunction identities, if you remember them, are nice to use when you recognize them. So one more thing that you're going to need, and I'm going to do it all for you, but the double angle identities. Like if I have cosine 2x, one thing that cosine 2x equals is 1 minus 2 sine squared x. Another thing it equals is 2 cosine squared x minus 1. So if I look at 5i, you have the limit as x approaches 0 of cosine 2x minus 1 over 2x squared. By the way, on every one of these you should be filling in the number first to make sure you've got 0 over 0, that you should even be doing techniques. You can't really compare cosine 2x minus 1. However, could you do this? Just a thought. We could think of this as cosine u right here. And maybe go back to one of our first identities where we have cosine u minus 1 over u, and it goes to 0. But I'm kind of thinking I'm going to use my double angle identities here. So cosine 2x is 1 minus 2 sine squared x minus 1 over 2x squared. My 1's cancel, and my 2's cancel. And so I have sine squared over x squared. That's sine x over sine x, and sine x over x, and sine x over x. And I still have this negative. I may have canceled too much to where you can't really read it. But if you look at 5i, you see your answer is -1. So those are some things to think about when you're working these identities.